Hi, hello, welcome you all to the Reliability Engineers Academy channel. So today we are going to discuss on a topic, an industrial AI briefing. Can AI replace the reliability engineers? Once again, I welcome you all to the today's session, and so we are going to talk about an topic: Can AI replace the reliability engineers? So, what missions will automate, and what only humans can still do? A field briefing for engineers and operation leaders on the RA channel. So let's welcome to this session. So the series, the Industrial AI channel series. So our first webinar on understanding the AI in terms of applications in the application of reliability engineering. So once again, the today's session and the topic: Can AI replace the reliability engineers? Every reliability leader is asking the same question: Will AI take our jobs? As AI will automate the large portion of traditional reliability work. I know the judgment, leadership, and operational instinct still needs a human. So every reliability leader are looking for the AI solution. And of course, and human judgment and leadership and operational instinct still need a humans to take the role of reliability engineers. What actually the reliability engineer does, and what reliability engineer does in its day-to-day business operation. There are 14 jobs as a one human the reliability engineer can do. And for decades, one of these tasks ran on manual calculations, historical analysis, and decades of an operational judgment. A reliability engineer can perform the root cause failure analysis and the failure analysis on the failed bearings or mechanical seals, whatever the equipment components or asset or systems. And a reliability engineers can perform an RCM, and a reliability engineer can perform the design FMEA, process FMEA, and FMECA, and preventive and predictive maintenance optimizations, and reliability data analysis, and variable and statistical analysis, the asset criticality assessment, spare parts optimization, risk-based inspections, RAM analysis, condition monitoring, and asset health modeling as well as monitoring. One human as a reliability engineer does all these 14 day-to-day activities or the task assigned to him. But what has changed? There are five technologies and one collapsing job descriptions are in place. And what has changed before and what we are looking from the AI and ML perspective. The first is learning, the second is forecasting, third one is sensing, and fourth one is mirroring, and fifth is rewriting or writing. So in terms of machine learning, the machine learning detects the patterns human miss in vibration, oil analysis, or in current and process data. In terms of forecasting, we have got predictive analytics, which estimates the remaining useful life and triggers the work orders before the failure. And the third thing is industrial IoT, which streams the millions of sensor tags per day from every asset on the plant floor, a digital tin, a real-time winner, a real-time virtual model of refineries, grids, and turbines for a risk scoring or live risk scoring or a live risk heat map for an asset performance, and Gen AI, which drafts the RCA reports, FMECAs, and dashboards in a minute. So together, AI can automate 8 of the 14 traditional tasks, and the list is growing every quarter. Yeah, where AI already wins, the failure predictions, and AI can automate more than 5,000 uh, asset tags in a second, a sensor tags of a gas turbine every second at millions of records per day. What AI can detect over a period of time, AI can take the raw data, uh, it can uh, build you the analysis which is required for you to predict the failure modes like bearing wear, pump cavitation, compressor surge, turbine blade damage, transformer insulation degradation, motor winding deterioration, and auto generator work orders. No human engineers can manually intercept this volume of data in real time At AI, that's that. So where all AI already wins, it help us to find the root cause and FMECA in seconds, from the event of corrective actions, from the event of failures, from the event of work orders, breakdown, corrective and emergency work orders. And here it helps us to ingest the data from the CMS system, uh, operation logs, alarms, and it helps us to convert that into the natural language processing phases, extracting the events, free text and entities, and correlating the patterns, and help us to diagnose and generate the and recommend the corrective actions as well as the preventive actions. AI that never stops watching the plant. AI help us to understand and help us to generate or automate the FMECAs and RCMs. It helps us to automate the equipment boundaries, failure modes, predicting the failure mechanisms, and ranking them with the recommended PM task as well as the spares and spare parts criticalities, and producing the full RCM worksheets. So where AI already wins, it helps us to do the 24 into 7 plant watch, help us to automate the return reports, which help us to generate the live asset health map. So here we can see that we have got a pump 101 and we got a heat exchanger and we got a vessel and we got a pump. It helps us to monitor the each and every asset, live asset health map, whether the asset is in critical condition or whether the asset is in a watch list or the asset where we need to optimize the things. So it will be drafted in a seconds, and you can see the Gen AI report where the daily briefing have been given as an example for you to understand that how the live asset health heat map is helping reliability engineers to understand the performance of our assets. So where this happens first, there are 10 industries already moving. The sectors where uptime is measured in millions per hour are the fastest adapters of AI driven reliability. So we know that the asset's performance been need to be balanced with cost, risk, and performance. So oil and gas, petrochemicals, power generations, transmissions and grids, minings, manufacturing, aviations, railways, marine, and data centers already adapting the AI. So if your sector is not here yet, so it will be within 24 months. So where AI breaks down, the four things AI still can't do. One is no operational instinct. AI can't walk the line, hear off the pitch motor, or smell overheating insulation, or sense an unsafe condition. But engineers diagnose using the institution built over a decade on the plant floor. Yeah, we've used the look, listen, feel technique. We use the total predictive maintenance, total productive maintenance, TPM techniques, operation driven reliability techniques. Uh, we use the Gemba walk, the operational walk down. And the next thing is no graphs of business risk. Yes, the production commitment, budget pressure, safety culture, regulatory exposure, and of course the political trade-offs. So these don't fit into the future vector of AI. So engineers weigh them on every day. The third thing is garbage in and danger out. The bad calibration, missing history, or sloppy CMMS coding, blank failure records. AI inherits every error in your data, but engineers knows what to be trusted and when to override it. So no leadership, no culture. So AI does not run workshops, mentor a junior, pursue a plant manager, or change a culture. So reliability is also a human discipline. The line between automatable and the human runs straight through the judgment, where four things that AI still can't do. So AI can handle these tasks, part of a machine work, volume, speed, repetition, where pattern detection is possible. So AI can predict and human can sense. So AI can predict the failure, forecasting, and human can sense through the judgment, context, ethics, leadership, and accountability. And AI help us to detect the anomalies, so the failure anomalies, and remaining useful life. And human judgment help us to weigh them in terms of cost, risk, and performance. AI help us to diagnose and automate the RCAs, wishbones, and 5-way generations. And the judgment decides shutdown feasibility emergency calls. AI help us to plan the FMECA and RCM in minutes, not in months. AI helps in governing, validating the AI models and catching the hallucinations. AI help us to optimize the spares and help us to perform the reliability analytics, stats, and all. And the human judgment will help us to compile the regulatory audit and safety case ownerships. He help us to generate the daily reports and the dashboards and 24 into 7 digital team support. And the human has to build the culture itself. The verdict is not an AI or engineer, it's an AI plus engineer. The new job description for AI augmented reliability engineer will be: the AI handles the repetitive analysis, data processing, failure prediction, report generation, pattern recognition, where human or engineers owns the strategic decisions, risk governance, AI validation, sustainability, ESG, digital transformation, and leadership. So engineers who can learn to direct an AI lead the next decade of industrial reliability. So here it's a skills for you, the 12 months roadmap to build. So you don't need a PhD in machine learning or AI. So the 10 skills to start to building today, you need working command of the language AI speaks and judgment layer above it. So you have to learn the data analysis, data analytics, machine learning fundamentals, and Python AI tools, and digital twin understanding, reliability data science, and IoT integration, advanced statistics, and AI governance, cybersecurity, and asset performance. Core, learn first, apply it, and then lead within a year. The future is not AI versus engineers, it's augmentation. So those who resist AI may eventually become absolute. So those who learn together or learn alongside it will lead a next generation of intelligent asset management. So thank you all. Thanks for watching this webinar and listening this lecture. And if this helped, keep the signals going and subscribe for more industrial AI channel and on the Reliability Engineers Academy. So build your first digital tin, a practical walkthrough for a single pump to a full unit in 30 days. And dropping the next Tuesday, you will catch up with the next webinar on the Reliability Engineers Academy channel. I once again thank you all. Thank you for joining this webinar.